So here we are at functions. We're going to focus on a specific type of function in this next chapter. We've already identified a function is when x does not repeat. We've seen them as ordered pairs. We've seen them in a graph. We've seen it as a mapping diagram. We've seen it in a table. But all of those came from an equation. And that equation models a situation. You've already developed some of these equations. But now you're going to take an equation and you're going to be able to graph it. You're going to be able to take an input, get an output, and you can see the pattern of that equation. So functions can be represented as an equation, and we call this equation the rule, okay? The equation will generate ordered pairs by taking an input, which is our x, plugging it in, and getting an output. The x value is always the independent, and the y value is always the dependent. The graph of an equation is the set of all ordered pairs, which most often will form a line or a curve of some sort, okay? Now the curves have different types of functions, okay? But you'll either get a line or a curve. So let's look at this. 1 and 2 were given equations. A function table allows us to order and keep things organized. Now here you have given x values. If you're not given the input, you can use possible inputs and create your own table, okay? But what we would do first is look at our equation. We're saying x is -1. So I replace x with -1. I do the math and I get 6. Therefore, my ordered pair is -1, 6. I go through and I do that again. I replace x with 0. I add 7 and get 7. So my ordered pair is 0, 7, okay? I replace x with 2, add 7 to get 9. So my ordered pair is 2, 9. Last, I'm going to replace x with 4, add 7, and I'll get 11. So my ordered pair there is 4, 11. When we are graphing a function from an equation, you can't just come up with 2 ordered pairs because sometimes we won't know what direction it's really going, and having about 3 or 4 will help us. Okay, look at our next one. My function says I take my input x, subtract 13, that gives me my y. So I do just that. I replace my input with 3, I subtract 13, and I get my y. So my ordered pair is 3, -10. I do the same with 6, so 6 minus 13 will give me -7. So my ordered pair is 6, -7. Replace my x with 9, subtract 13, I get -4. 9, -4. Finally, I replace my x with 12, I subtract to get -1, so 12, -1. On both problems, notice what I did here. When I replaced x, I used a parentheses. It is very important that you do this because their problems are going to build. So here's 2 more. Don't panic. Just because they're a fraction, take out your calculator. Pause and try these on your own because we're going to go over them quickly. Okay. If you look here, all I did, I still just replaced x with its value. However, since you're multiplying it by something, it's super important that you do put your x value in parentheses, okay? Notice the x values that were chosen. If you look, I have a -6, a -2, a 0, and a 14. Every single one of those x's can be divided by the denominator evenly. And there's a reason that I did that. Whenever I have a fraction coefficient, meaning I have a fraction in front of my x, I choose inputs that are easily divisible. Because when you multiply the fraction by the whole number, it will help you result in a whole number. You could have picked 5, but then you would have had decimals. And sometimes for some of us, that's a little bit more confusing than for others, okay? So if you did not do number 6, pause now and try it so that you can figure out how we're getting these answers. So here's number 6. So again, my input values, if you look at them and you look at the denominator of my fraction was 3. So I chose numbers that can be divided by 3. Now look to the right of my problem. I went and I actually did the math. Some of you can't do this in your head, and we're noticing you're trying to do multi-step things with just a calculator. You're not actually writing it down. There's nothing wrong with going through the process. And moving forward with this next unit and every unit here on out, if you guys don't show work, we're not going to give that credit. You need to do the work, okay? So if you want our help, piece of paper out, pencil, writing it down. Okay, so these all are divisible by that 3. So now this is the same exact thing we've been doing, everybody, except I haven't drawn a table. There's no table drawn. Doesn't mean you can't do the process. So if you look, our equation is y equals x minus 5. They gave me 3 domain values. Well, what is domain? Domain is my x. So I take my first one and I replace x with 4. I subtract to get -1. I go do the same process. Rewrite your equation, and yes, you need to write it like this every single time. I replace x with 6 to get a +1. I rewrite my equation. I plug in my 8. I subtract to get 3. Therefore, this is not your answer. My range is -1, 1, and 3. That there is your answer, and that there is how you need to write it. Okay? So take a look at number 8. It's the same thing. They gave me my domain, so they gave me my x's. I have a coefficient now. I have something in front of that x. So this is where you want to use parentheses. So 3 times a -1 is a -3. Plus 1 is a -2. I rewrite my equation again. I replace my x with 0. 0 plus 1 is 1. But there's one more domain value, so I replace my x with 1. 3 times 1 is 3. 3 plus 1 is 4. Then finally, your answer you would write would be -2, 1, and 4. Ladies and gentlemen, if you do this work, if you write it out step by step by step, Miss Nell and I are able to see where you're going wrong, what the mistake is. But if all you're doing is punching numbers in a calculator, we can't figure out what you're not getting, okay? So right now, I want you to pause and try these on your own. Okay, we're going to be looking for those because I'm not giving you the answers, but we're looking for the detailed work. So why? Why do this? Why find the outputs for the inputs? Well, it's because I need to graph my function. I need to take my equation and put it to a graph. So this is one way, and I'm going to say this again, this is only one way to do that. But if I go through my process we've done, I replace x with -7, I get a -4, there's my ordered pair. Go ahead, you can work ahead. I replace x with -3, I end up with a 0. So -3, 0. That's actually an intercept. I replace x with 0. Add 3 to get 3, 0, 3. I replace x with 2, I get 5. There's my ordered pair there. And last but not least, 5 plus 3 is 8. So 5, 8. There's a reason I did this. So now I've got ordered pairs that I can go graph. Remember, when we graph an ordered pair, I start at my origin. I move right if it's positive x, or I move left if it was a negative x. After I've gone left or right, I kind of pause. Then I decide if I'm going to go up for a positive y or down for a negative y. So let's look. I've got -7, -4. So I'm going to go left 7, down 4. I go left 3 and stay put because there was no y. I was at 0. Now my next one, I don't go left or right. I stay put at 0 and I move up 3. Finally, I move right 2 and up 5. And then I move right 5 and up 8. Okay? Now I connect those. I've just graphed my function. This is the tried and true way, no matter what, every single time. If you forget the shortcuts we're going to teach you, okay, you can always go back to a table. And for any type of function, you can do a table. So if I move on to my next one, okay, now I have x squared. Same thing. I replace x, but look, you need to use parentheses. -3 squared is 9. So I got -3, 9. Use parentheses. I get 4. 0 squared is 0. Okay. 2 squared is 4. And then 3 squared is 9. So I've got my ordered pairs. So I go plot. -3, 9. -2, 4. 0, 0. 2, 4. And 3, 9. Now, when I connect these, it's kind of a U. Notice there's a little kind of curve at the bottom, okay? So when I did these two graphs, the very first equation, remember it was x plus 3. Y equals x plus 3. It produced a line. So it's called a linear equation. When I just have an x and my exponent is 1, it's linear. The second was x squared. My x has a square on it. It produced a U shape. So it's called a quadratic equation. This next chapter, we're going to focus on graphing linear equations, okay? So I need you guys to make sure you have everything jotted down. Go back. This page right here is very vital. If you circle x plus 3, linear. X squared, quadratic. If the x has an exponent of 1, it is linear. You need to be able to identify from an equation.